All right, so let's get started. My name is Joe Specht. I'm the Vice President of Enterprise Applications here at Tableau. Previously, my teams have run Tableau Online and Tableau Public. So for the last 4 years, we built that into the system that it is today. With me today is Ketan Lamba. Ketan is Senior Manager of Engineering in the online and public space. Handles mostly online, and so he'll also be joining me for the second half talk specifically about online. Before joining Tableau, I was running the internet operations for the Walt Disney Internet Group, Expedia, and ESPN prior to that. I've been in the industry for about 20 years, in the internet industry for about 20 years, which makes me feel really old. And I have a granddaughter, which also makes me feel old. I'm always excited to talk to our customers. I'm an ops guy, and so I don't always get that opportunity to talk to our customers. And so at conference, I love it because I get to interact and talk with everybody here. So today we're going to talk about how we scale Tableau Online and Tableau Public with the idea that what we want you all to get out of this is comfort in knowing that Tableau Server can scale. It's Tableau Server under the covers, and so our goal here is to just show it off so you have comfort that your server implementation can be built to scale. And we'll spend lots of time talking about that, some time talking about the architecture for both environments, and then a little bit of time talking about the tools that we use to run those environments. At the end, especially with a small team like this, we'll have more time for Q&A, and so we'll actually try to make it a little bit faster on the presentation side so that we have more interactive time with everybody. So let's get started. I already said welcome. So Tableau Public. Tableau Public is Tableau Server running at scale. As you know, Tableau Public is all about sharing your stories with data for free. Anybody can use Tableau Public. It's completely free. You upload, publish a viz up there. Everybody in the world can see it. You can put some restrictions on what can be downloaded, but it's there to share with everybody. And the idea, if you haven't used it before, is you can go get some of these very, very complex dashboards that are published up there, and you can download them and then deconstruct them, which is very valuable. Especially when you're learning how to do Tableau, it's a very valuable resource for that. Or a lot of media organizations use Tableau Public. This example is from an Ecuadorian newspaper publishing basically the Olympic schedule. It was actually our #1 visualization on Tableau Public for this entire year because it was on the front side of their front page of their newspaper for weeks and weeks. It wasn't the highest single day hit, but it was the highest overall number of pages visited for us. So when you're on the front page of major websites, so we've been embedded in MSNBC and the New York Daily News, the Daily Mail in the UK, in a lot of different places. And so when you have to be up all the time, and our background is in, Ketan also comes from Amazon. Our background is in building production internet-facing websites, and when you have to be on the front page of somebody's website and they trust you to do that, you have to be up all the time. So not only does Tableau Server scale, it's really, really robust, and you can design it so that it can withstand HA in a number of scenarios. And I'll talk a little bit about how we actually do that for our Alpo internal server a little bit later. So besides media organizations, a number of public universities use us, and this is an example from Cornell. Cornell uses it to publish their acceptance rates for different, based on different factors. And so that's a big one. Massive online open courses also use us, and I'll talk about that a little bit later. And then individuals. This is a blogger, OSM guy. He's talking about the likelihood of making it to professional sports as a high school athlete. And as a high school hockey player in Alaska, that was actually one of the best chances you have, but I didn't get anywhere close, except for having some really awesome hockey hair, like my favorite player, Jaromir Jagr. So, if I was running Tableau Server, we're going to talk about how it scales. In December 2015, the Daily, let's see, this was from the Daily Mail in the UK published this on their website. A link to this on their website is from Nat Sen, which is a research agency focused on social media research, and they published the attitudes towards Brexit embedded in the Daily Mail website, and we saw a lot of traffic. This is the number of sessions for 1 hour. This is at the, let's see, this is at the 3 a.m. hour Pacific time, and we had over 280,000 concurrent sessions during that time on Tableau Public. So sessions is the thing that most on-premise implementations care about, and 280,000 sessions is a ton, right? And we didn't sweat really. Like I didn't even actually know that this was going on when it was happening. So we're pretty robustly built out, and I'll talk about the architecture in a second. But just to give you some comfort for, hey, can I build my on-premises system to really scale out? 280,000, that's a lot. That resulted in, let's see, in this case, about 2.9 million hits. So that's mouse overs and clicks to change the viz and whatever. So during that hour, we did 2.9 million. Now, that's not the most number of hits that we've ever done in Tableau Public. That was actually the one I presented on last year, which was from an Argentinian newspaper that published a page on their front page. And you can see that on the left, which was over 3 million hits. But it actually didn't have as many sessions because it wasn't as interactive. So we've talked about sessions, 280,000 sessions peak that we've done this year for public hits, 2.9 million or 3 million last year, and then publishes. So we were as a part of a massive online open course that I think MIT did. To get credit for this course, the students had to download some data, make a visualization, and then publish it to Tableau Public to get credit. It was due on a Monday. I remember this very, very well. And like most people, like myself, people procrastinate. And I just finished this presentation on Tuesday, by the way. And they procrastinate, and they published almost all those workbooks that they needed to do in like the last hour before noon when it was actually due. And so we had 4,010 meg workbooks published, mostly in 1 hour, but the stat is in 1 day, 4,000 publishes of some pretty big workbooks in 1 day. And so I talked to some of our largest customers, and some of you are in here, and 4,000 workbooks isn't something that even our largest customers do in a day. And it's pretty uncommon, and this one was a special example. So the last thing kind of in this vein that I want to talk about, because remember this is server running under the covers, is every release candidate for server goes to public first for 48 hours. And we spent a lot of time on load testing. We spent a lot of time and money on load testing, and I was responsible for the capital budget, so I know exactly how much we spent in money to provide load testing scenarios for our teams. And even with all the best scenarios that we can come up with, putting it on public and letting real users hammer at it for 48 hours makes a material difference. Because I don't think this year we've stopped any releases, but there's been at least 2 times in the past where we've put something up, we thought we were ready to go, and it got out to public, and with all those users hitting it, doing all kinds of interesting things with it and all kinds of scenarios, like, oh, we found a bug, halt the release, patch it, fix it, re-release it to public again for 48 hours before it comes down to you for an on-premise implementation. So just to give you all a little confidence in, we really want what you get to be as high quality as we can possibly make it. So let's talk about how it scales worldwide. One of the things that I get asked often is, well, how do you scale it worldwide? So this is that same viz, just with putting the hits where all those requests came from across the globe. And you can see that we serve pretty much everywhere in the world, from Santa Clara, California, where our primary facility is for Tableau Public. So all of these hits that you can see on this map are all eventually hitting our servers in Santa Clara. So, and the reason for that is we're doing, as you guys probably know, all the number crunching happens on the back end near the data, right? And then what is actually served out is just the results of that, right? And that's pretty small, what's served back to the browser. And so that's pretty easy to serve even at a remote location. So if we drill in a little bit more to that section with the UK Daily Mail that I talked about earlier, you can see that a great number of those hits came from the UK, and then some of them came from the US. But their primary focus in the UK, as you would expect. And then finally, just if we use Tableau's tool to be able to just zoom in there, you can see that 1.17 million of those hits for that hour came from Europe. So we get a ton of hits remotely, and because of the actual underneath, it's not something special we've done for Tableau Public, but underneath, what's actually getting served back to the browser is very small. So, and that's all, and you can see the little Tableau logo where our actual primary facility is. All right, so let's talk about the architecture here. I'm going to start, come in from the internet and then go counterclockwise on this diagram. So come in through the internet, you hit firewalls, then you hit F5s, hardware load balancers. This is another example of why Tableau Public and Tableau Online are very important to on-premises servers, is that everything that we do in Tableau Public and Online, we try to roll back into to the on-premise implementation as much as possible. Hardware-based load balancers are an example of something that started in public and then made their way back, and you can use, we have a white paper and a standard configuration that you can use for your on-premises implementation using a hardware load balancer to offload connections. It provides security. It does a lot. There's a lot of things that you can do, depending on how much money you want to spend with F5, to allow you to do very interesting things, especially around security and WAF. If you're interested in that, come talk to me afterwards. So moving around to the left on the diagram here is the Tableau application servers. Those are workers in the on-premises implementation. We kind of break them up between application servers and backgrounders. But in the workers, we have about 30 workers, 30 VM workers. They're 8 core machines each with 32 gigs of RAM. We have 30. We don't need that many to run, but when, again, designing for an HA scenario where you could have a complete rack failure, you have to design around that. So there's probably about a third more than we actually need to have in there, but you have to be able to design for a peak HA scenario. So moving down is the 2 boxes, the orange boxes and the pink boxes, make up what in an on-premise implementation is a repository. One side is the file server, and the other side is the Postgres server. The Postgres, in all cases, we use SSDs for those systems. The file servers are the extracts that happen and get pushed out there from doing extract refreshes and things like that on the backgrounders, and those are the TDE files that you see when you're looking, if you ever go and explore the file system on your primary. A couple of notes on those. They're about 16 gig, or 16 core systems with 128 gigs of RAM on the database server. The file server has less RAM because it doesn't need it. We use SSDs there, but the primary reason we use SSD is not for IOPS or throughput. It's for preventing contention, right? So in a spinning disk scenario, the head has to seek somewhere else, and when we're serving all these views all over the world, we want to reduce that opportunity for contention between 2 people doing 2 different things at the same time. So there's no seek time to get, basically no seek time to get over there. And then coming around, you can see on the right-hand side that we have backgrounders. That's something new for Tableau Public. This year is the first year that we implemented the ability to do refreshes on Google Sheets. And so we put in, just recently put in backgrounders for Tableau Public. They're not really heavily used at this point, and we're kind of seeing what the uptake is in people using Google Sheets before we decide how many of those we had. If we would have had a massive, oh yeah, that's what I've been waiting for, we had to build out pretty heavy. It hasn't been that case so far, so we'll probably reduce those. But as you know, on on-premise implementations, it's good to separate the backgrounder processes from the worker processes, because the backgrounder processes, when they run, they take all available resources to try and get their job done as fast as possible. Network, server, storage, disk, whatever they can take. And so it's a good idea to separate that out from people actually rendering vises. And then finally, query cache, and I'll talk a little bit about that more on our when we talk about our Alpo, our internal implementation. But the query cache should basically is there to distribute the queries so that if, and especially for public, where we have a lot of people coming as the same context, it's really, really effective for public because there's not a lot of, not a lot of conflict between like username as an example, as something that would not be cacheable between two separate people. All right, so let's talk about our on-premises implementation. This is Alpo. Alpo is our dog fooding server. We also run all on-premise release candidates on Alpo after they go to public, they go to Alpo before we give it out to our customers for at least 24 hours. So there's 36 hours, unless it's an emergency hot fix, that server release candidates have to go through testing before they get out to you to provide the utmost quality that we can. So the top half of this diagram is one implementation that we call Alpo A. That's the one that we run on most times through the hardware load balancer. The bottom half is passive. It is not on unless we have failed over to it. So it's an active passive scenario. And that, especially for on-premises implementations, that prevents it from being a billable asset because the one side is only one running. So you only have one running at a time, so you don't have to pay for all cores on both sides. Alpo is a 96 core total implementation. So that's comparable to some of our bigger, and is less than some of our bigger sites that I know are out there. But it's a fairly sizable implementation of Tableau Server. You can see here on the top one where we have the workers and backgrounders split out, the one with all those backgrounder processes on the right. And then we run query cache distributed as much as possible again in this implementation. We use the hardware load balancer to fail over to the Alpo B when we're going to do upgrades. So if we're going to upgrade Tableau Server, we fail over to Alpo B, do the upgrade on Alpo A, and then fail back to Alpo A when we think it's ready. That gives us no downtime for our customers, and so all of Tableau sales, all of Tableau finance, everybody uses Tableau, uses Alpo to do their job, and we'll have QA at the end. We'll have a lot of time for it with this smaller group. But they also have SSDs, like we talked about earlier, for that same reason. So tools that you probably know about, but I just want to make sure you guys are aware of. We have TabJolt. TabJolt is a load testing tool. So you can take TabJolt, download it from, just go to www.tableau.com, search for TabJolt, download it, and you can load test your workbooks on your servers using the same basic set of tooling that we use to load test Tableau Server for us. So it's a very good tool. It's been out for just over a year. I talked about it last conference, I think, is when it just came out, but it's very valuable. And then something that's fairly new is LogShark. So LogShark, again, just search on www.tableau.com for LogShark. LogShark is an analysis tool. So it takes all logs, puts them in MongoDB, gets a subset of that out to Postgres, and then allows you to visualize what's going on your server. So with LogShark, you can see things like, hey, what are the exception messages, the failing workbooks, and the background jobs, how long are they taking, things like that on an individual basis, and do analysis to help you tune and perform your Tableau Server implementation. And when you call Tableau support, they actually use this as one of their tools that they use to give you support. So it's the real deal, and it's something we use internally on both these. So for my part, for the summary, we talked about how Tableau Server scales. Views, we serve a ton of concurrent sessions. Publishing, we talked about that massive online open course. It scales globally. We talked about how that works. And then does your on-premises system scale too? Everything we do in public and online is Tableau Server under the covers. So our internal Alpo implementation, we use it every day to do our job. We talked about the load testing tools. and we talked about a log chart. So with that, that's the public section. I'm going to bring up Kate and Lamba, who's going to talk about Tableau Online. Thanks, Kate.
Hey. Thanks, Joe. All right, Tableau Online. While most of you have been wondering whether the Tableau server really scales for the SaaS use case. So we're going to find that out in the next 10, 15 minutes. All right. So, well, marketing wanted me to put this slide in, despite me telling them I'm a bad salesman, but they still wanted me to put this in. But in all seriousness, organizations do not want to spend time on thinking about hardware specs, provisioning, security. They don't want to spend time thinking about these things where we can help them there, right? You think about Tableau Online, you can sign up in minutes. You can roll it out to your entire organization in a matter of 30 minutes, an hour. You can set up everything that you need to get them started with Tableau. So it's especially great for organizations which are cloud first. You get started quickly. Who really enjoys getting paged for VPN configuration issues and firewalls, right? Nobody enjoys that, especially when your field staff is looking at their Tableau sales dashboard and trying to figure out their opportunities. We can help that. Our goal with Tableau Online is make it easy for you to access your content on your mobile phone, your tablet, in the field without needing all those kind of configurations. Security. It's an expensive insurance policy. We all know that. You know, defense is expensive, attack is cheap. We can help you there. We've done a lot of work in designing good code review practices, threat modeling. We do a lot of white hat testing. All of this is going to help because we make sure that your content is secure with Tableau Online. And to top it all, we provide a very simple single sign-on solution using SAML. So the credentials to your Tableau Online site are secured by your own identity provider. You can choose Okta, you can choose Ping Identity, you can choose one login. It's all there for you, and it's simple to set up. All right, so we're going to start talking about a little bit more about Tableau Online. I want to talk about what the problems we are facing. And these problems, the first problem probably is something that you've already seen or you're going to see soon. A growth in our user engagement, 100% year over year, which is fueling a thirst for computational capacity. And just to give you a sense, what I have here is a comparison of 2 weeks, one in 2015, one in 2016, the average daily count of background tasks that we spent, and the compute time that we did to just finish those tasks on our largest online cluster. So you can see in just 13 months, we grew like 13x on the average daily task, 9x in the CPU time we spent to finish those tasks, and about a 5x growth in servers. This is expensive. If you go this direction, you can see how Joe is going to hate me when his CapEx budgets get hit, right? So we had to make some significant investments, and we all know the reasons why this is happening. The users are getting engaged, they're getting value out of Tableau, and they want to start publishing, they want to start refreshing their content, they want to get their organization into this thing, right? And for us, this was a big challenge. We had to make some significant investments in architecture and features to make sure we keep up with this growth. Just throwing hardware was not going to work for us. Okay, so I'm going to talk a little bit about our scaling challenges, and then our solution, our strategy, and then we'll dig deeper into the architecture. So the first thing was the two bottlenecks in our architecture, which if you run a cluster today, you're pretty much aware of it. One is the Postgres database, which is your familiar workgroup server. It starts degrading when you have a large number of connections or a large number of transactions happening, especially at peak loads. And you'll see database brownouts, and the system just dies. The second thing you're going to see is our TD file store. So in online, we store all the TDs on one single file store. And we'll talk a little bit about more when we go into the architecture why we did this thing. The point here is the IOPS start hitting a limit especially when customers start publishing extensively. We start seeing the extract refreshes that I just showed you the numbers slide back. We had to figure something out. So our strategy involved building out completely self-contained clusters that we call pods. And each pod essentially hosts a group of customer sites. The second thing we did was we built a dynamic lookup cache using Cassandra. And what that allowed us to do was you come in through the same front door. So you come in through online.tableau.com, but we look up immediately who you are and then decide, all right, which site do you want to go to? And then you route you to the right pod where your content is hosted. And finally, we built a bunch of shared services, which are active support. So they have delivered through multiple data centers. So one of those is signed in, and the other one is user provisioning. OK, so the big thing that I want to talk about from a big takeaway of why we chose this was time to market. Our business was growing so fast, we didn't know the latent demand that existed for the SaaS solution, and we were caught off guard by it. And this strategy allowed us to get and meet that requirements and the business needs quickly without doing a significant overhaul of the entire Tableau server code base. So let's get deeper into the pod architecture. All right, so pull it up, great. All right, so as I said at the top, you come through the same front door, online.tableau.com. You're routed to either of the two pods. I've just shown two pods here, but we have about 4 pods now. And when the user comes in, if the user is a member of multiple sites, so you have access to multiple sites, you'll be presented with a site disambiguation box. And I'm going to show a demo in a second. And you can select your site. And as soon as you select your site, we make sure we look up, hey, which is the location? Where is the address for your site in our cache? And then we route you there. Each pod is essentially consists of about anywhere from 12 to 24 workers. It contains isolated, dedicated backgrounders that Joe talked about, anywhere from 8 to 25. In fact, our largest pod today, which is 10AY, has about 49 total workers. OK, all right. The other thing we do is we have an enterprise solution called Commvault, which allows us to do timely snapshots of our TDEs and our database, which allows us to back them up. So if you have to restore content, we can restore content from there. The big thing that I wanted to talk about from an online perspective is our workers are isolated. So they don't know about other workers. They don't talk to each other. What that allows us to do is we can take half of the cluster out of the load balancer, upgrade it, put it back in, take the other half out, like the standard way that has been done in the past. So what this does is we have rolling upgrades in online. You will not see downtime in online. OK, so what does the pod architecture get us? The first thing is compliance. We are able to meet the legal guidelines of an industry or a territory. For example, our EU customers really love us that all their content is in our Dublin data center. Second thing, consistency. So all our pods have the same architecture. We have built-in automation so that we can build these pods within 4 hours and roll them out quickly. And we use the same deployment pipeline to push bits to these pods. So the management of these pods is pretty much automated. We don't spend any more dollars on that. That makes our life easy, especially our ops team. OK, the third thing for us is isolation. Each pod hosts a group of sites. So any performance degradation that we see, any kind of big spike in sessions we see, all of that is limited to that pod. Our customers on other pods are not affected. It's one way of us making sure the fallout radius from an event is limited to a particular pod. OK. So while we were scaling Tableau Online, we learned some pretty hard lessons. The first one was when we started, we didn't know what the market was going to be. And we rolled this thing out, we saw the growth, and we were caught off guard. So one lesson we have learned is, for example, our storage solution. We have changed our storage solution 3 times in the past 3 years. In fact, our extract count went from 1 terabyte to 4 terabytes in just 6 months. We realized when you're dealing with storage solutions, go for the enterprise solution. Initially, it comes out to be a little bit expensive, but in the long run, it's way cheaper. You have a way cleaner story about upgrading, adding more capacity, compared to any custom solution you would come up with. This summer, we learned this lesson. Don't DDoS yourself. We schedule jobs in Tableau Server. This summer, we upgraded 9.3, and one of our big features, which is the online sync agent. So if you guys don't know, the online sync agent essentially allows our customers to schedule extract refreshes for their local data extracts. The growth in sync client went about 60% in 3 months. And we were seeing our customers publishing a whole lot in 6 a.m. to 9 a.m. window. And they were doing it every 15 minutes. The other thing was our growth from our normal customers who were using server refreshes went like 100% in just 6 months. The result was on the hour, we were seeing brownouts in our database. So the lesson we learned is if we are going to write a syncing client for refreshes, we started adding some randomization. So even when customers said they want to have it run at 9 a.m., we added a window of plus minus 3 minutes so that all the sync clients don't hit us at 9 a.m. Okay. When it comes to databases, hire an expert. That was the hard lesson we learned. And what does the expert buy you? The expert will really help you tune your queries. Queries which run at 50 milliseconds for a 10 million data table, at peaks is going to become your bottleneck. What I have here is a graph showing at 75th percentile latency value for a permissions query in online. As you can see, the number of operations per second has been increasing over time, but our latency has actually gone down. The guy who we hired helped us pick out the anti-patterns in our application code. He helped us tune the query. So it's worth paying the expert. Finally, we were looking at the data over the last 6 months for online, and we noticed that about 25% of our compute capacity was being wasted on failed refreshes for incremental and full extracts. The result was simple. A lot of our customer requests were sitting in queues, so they were choosing to start at 4 a.m. They would not start until 6 a.m. We were clearly missing our internal SLAs for completion times. And to top it all, to meet those SLAs, we kept adding backgrounders. So that was a cost that we were paying. So a couple of things that we did. First thing, we started building a feature when your refresh fails, you're going to get an email. So this was kind of a nice nudge to our customers saying, go look at your refreshes task. They must be, you have a wrong password, your server name has changed, something has changed, please go look at it. The second thing we did is a little bit more hardcore. If a customer refresh task failed like 5 times in a row, we would just suspend it and send an email to the customer that your task has been suspended, please go take some action about it. And that helped us recover about 20% of our compute capacity. So we had to build those features out to keep up with the demand, as well as rectify some of the actions that our customers were not taking. All right, so where were we heading in 2017? Well, the first thing is we moved to AWS for one of our pods. So in October 2017, we launched a new pod, which is all on AWS. The reason we went to AWS, we wanted to use infrastructure components which were designed to handle failures gracefully. For example, we use RDS, hosted Postgres. We have moved to a 2 data center model for delivering content. We use CloudFront for our CDN. We use ELBs. All of these PCs are cheaper for us to run, and they offer us higher availability, which matters a lot to our customers. Come next year, we plan on moving to a Linux pod on AWS. We plan on using 3 availability zones within availability region, so it's kind of have more uptime, more failover story, better failover story. And finally, we're going to enable auto-scaling. So our goal is to enable auto-scaling starting with the backgrounders, especially because we know the backgrounders are not busy throughout the day. They only become busy for our customers during the off-peak hours. All right, finally. So Joe was talking about some of the tools that they use for public. We use a couple of tools in online for monitoring. We use a time series database called Graphite with Grafana on it for capacity planning. We use Splunk for log analysis. We use New Relic. New Relic is new to us. The reason we chose New Relic is it has an amazing smartphone app, so we can monitor our site health really anywhere, anytime. We use Google BigQuery for taking snapshots of our database, our Postgres database, and we pump all of this data into Tableau. All right, so in summary, I did talk about some of the bottlenecks that we have. I described our scaling solution. And then the final thing is where we are heading in 2017 with the evolution of our architecture. The thing that I want to leave you guys with is Tableau Server scales. It scales for your needs. It scales for the SaaS use case. It scales for the public use case. All right, so I want to invite Joe back up here. We have some time for Q&A. Yes? Mm-hmm. Correct.
Yeah, so the question is, can you talk more, Ketan, about how we do rolling upgrades and treating each of those workers separately?
Okay, so the on-premise solution today treats workers as if they're talking to each other. You use the Apache Gateway, which is the main load balancer for you. For online and also for public, we chose to use the external load balancer. And our Apache load balancer only routes on the host itself. So there are some implications for it. For example, some of the processes for, say the WIS-portal process can only talk to the data engine process on the host, right? What it means is your initial outlay for coming up with a big implementation may require a large number of hosts, but then it affords you the flexibility of doing rolling upgrades, as I mentioned in my presentation. You can take half the cluster out, go upgrade it, put it back in, take the other half cluster out, upgrade it again, and put it back in.
So essentially, is that almost like they're all independent single server implementations?
Exactly.
They're actually front-end to different load balancers.
Correct. So we can horizontally scale within the pod with the external load balancer. And we have rewritten some of the rules, the routing rules that the gateway has to route just locally.
Yeah, so the only thing I would add to that is, we talked a little bit earlier about things we do in public and online rolling back into the on-premise implementation. We don't have a configuration right now that we can apply that to the on-premises implementation. But as I showed in the Alpo implementation. I don't know if you were here for that part, but that shows how you can do a similar thing, flipping A to B to do your upgrades.
That's my question. If
Next
you
question.
Back the Alpo A, Alpo B to an upgrade.
Yeah, so
Go down a little bit more. What happened during the upgrade? How you can do the workbook publishing?
good catch.
At all.
Okay,
Do the backup
so
along to-
I'm repeating all the questions because this is being recorded and you can play it back later. So the question is, hey, Joe, you showed Alpo, the Alpo implementation. I'm trying to get back there in the presentation. How can you do publishing when you're doing your upgrades in that scenario where you failed over to a second repository or a completely second implementation? And the direct answer, oops, this is it. The direct answer is we turn off publishing. So we do it at night. It does have that that concern, and it says you're on Alpo B. You can change the logo in the upper corner of your server implementation. We changed the logo to say, hey, you're on Alpo B, and you have publishing has been disabled. So to directly answer your question, we do that. One of the things that we do is we replicate the scheduled jobs, the refreshes between the two. So actually, both servers are getting the refreshes of the data, the background tasks to do the refreshing. So we actually put double the load on our databases that are getting extracted from because we're doing them both basically at the same time. And actually, it was a really hard troubleshooting question to figure out why this one refresh doesn't work when it runs automatically, but I run it manually every time and it works because I was only running it manually on one of the implementations.
Follow-up question. Let's say when you do a backup midnight, then you start with the upgrade. How long the backup took? What happens?
All right. So the question is, hey, when you do a backup and then you're going to do your upgrade, how long is the delta? I think is the question. So remember, we failed over now. So let's play this through on kind of a step-by-step basis. So we failed over to Alpo B. We take the backup of Alpo A. Alpo B is not getting published to, so no content changes are happening on Alpo B. We do the upgrade on Alpo A. If Alpo A was to fail, we would then restore the backup and then cut back over to it. Does that make sense to everybody?
Yes, but even that, when you fail over to Alpo B, the B doesn't have latest data you have.
B does have the latest data because it remember, is running the refresh jobs in the background. So the only thing that it doesn't have is the ability to publish workbooks. So
All the workbooks. You refresh one day, but what about workbook? I just published to A. What happened with my workbook?
if it published to A, it got replicated to B. File replication, we can talk about that offline. That's a good question. There's some trickery here, and we can provide it to you. And so for those of you that want to do this scenario, come talk to me afterwards. I'll get you in touch with our architect who did that to get you the exact scripts to do so. But that's a great question. All those get replicated. I think they get backed up and then restored is the actual replication process. All right, next question. Great question, by the way. Go ahead.
Two questions. What do you find is the break point for stepping off Tableau Online and getting your own server? Or what have you seen as the break point? And then the second question would be, how do you limit, I guess, or is there any plans to limit users in case someone decides to just go crazy on the workbook?
Okay, so the question is in Tableau Online, what's the breakpoint between cutting over and just buying your own server? And the second question is, what do you do to prevent a noisy neighbor scenario where one user overtakes the capacity of Tableau Online? So I'll answer the first one. I'll let Kaiten answer the second one. So on the first one, it's kind of up to the customer. I haven't necessarily seen a breakpoint because it's kind of a different use case specifically. What I typically have seen is people who are a cloud-first company don't even want to touch on on-premise implementation. And we have some, some users that are 10. I think 10,000 is our biggest. 10,000 plus is our biggest site on Tableau Online. So it's a big implementation for Tableau Online. So there's not really a breakpoint. It's more of a philosophy and what you're trying to get accomplished with that. And then as far as the second one on limitations on what do people limit, or what do we limit from preventing a noisy neighbor scenario, I'll let Caton answer that.
Right. I'll add a couple of things to what Joe said in the first question. There are also scenarios where there are organizations which do not have any IT support. They don't have data centers, they don't have servers, they don't want to deal with that, right? And then we also have a lot of our customers who are like our partners, or like OEMs, and they work as consulting firms which build dashboards for their specific customer base. And they build multiple sites. So one of our customers, for example, Chain Analytics, has like 40 sites, and each dedicated to an individual customer. So there are a couple of scenarios where online makes more sense for them. Going to the second question, we have throttling in place. So when some customer is doing some extensive activity, we do notice that, and we can throttle those customers. The other piece is the Tableau server comes built in with a feature called Server Resource Manager. So, which is a little bit of a more, I would say, a nuclear option. Because if a customer does some activity which is pretty heavy, we have configured our SRM settings in a way that the process gets recycled. But the impact of that is that other customer sessions which are running on the same process also get affected by it. So our first goal is to do a throttling, and then we have a nuclear option in the back end, which is SRM.
Yeah, let me just add a little more color in addition to that. Remember, the architecture for Tableau Online is a wide distribution of servers. So at any point in time, even if you have a noisy neighbor, it's a noisy neighbor on an individual process on an individual server, right? So there's multiple processes on servers that answer the requests. And again, there's multiple servers spread out pretty wide horizontally. So in that scenario, we don't see a ton of that scenario, but when we do see it, our NOC is watching for it. We've reached out to customers. There's probably nobody in here, I guess. But we reach out to customers and say, hey, what's going on? Oh, well, we're doing a load test. OK, cool. Next time, could you let us know? And could you do it during this time, and we'll coordinate, right? And so if you're a customer, you're going to do a load test, please do coordinate with support, and we'll make sure we don't block you from doing that. Actually, 1 second. He was first. Sorry. Go ahead.
Two different questions. First is regards to AWS for Tableau Online. Is the intent to move all of Tableau Online to AWS, or to have some Tableau Online to AWS, some Tableau hosted?
So the question is, hey, tell me more about Tableau Online and AWS. Is the intention to move everything to AWS, or are you going to have both?
So the way to answer that question right now is we're looking at Linux, which we believe is going to be a big feature for us in saving costs. So as soon as we have Linux, we are going to closely evaluate running a pod with Linux in AWS and then making that decision. Our leaning is that going to AWS is not just a cost decision, it's also about keeping up with the business needs. It's faster to grow. There's ability to have auto scaling, so you can use your resources much better. You have better utilization of your resources. So going to AWS is not just about cost, it's also about those two things.
For those of us already on AWS, like AWS Redshift, I can see the advantage.
Right.
If you have that, is there a way that we can specify what zone we want? Say we want to be on the AWS when it's available, be on AWS
Yes.
as opposed to the hosted?
So what will happen? So your question is, can I select which AWS region I want to be on? So the good point is, yes, we're talking about data gravity here. So if your Redshift is hosted in the US West region, or it's hosted in the US East region, when you create your site, at the site activation time, you're going to be an option to say, do I want to go to US East? I want to go to US West. And you can choose that. And if your data gravity moves, say, for example, from US East to US West, or you move to Dublin or somewhere else, we can also migrate your site and its content, just what the Tableau server already has. Take that capability and move the contents to the new location that you want to.
And for clarity, currently there's only a US East pod.
Right. There's only one US
There's
East
a
site.
West. The other pods, there's 2 other locations basically for the other primary locations for the other pods, which is in Santa Clara, which may meet a West need, even though it's not in AWS, and in Dublin.
Okay, one other question, a math question. I've always been told that Tableau servers only address 8 GB of RAM per core, and that's been every session I've ever gone to. They said that the recommendation was 8 gigabytes, and then I'm saying on the Alpha A, on Alpha B it's 8 gigabytes per core. Is there something that is different on this architecture than when I go to all my server classes? You're always saying beyond 8 gigabytes per core on Windows didn't make any difference?
I'm not sure where that came from.
Session on Tableau server.
Yeah, I'll check with them about the initial recommendation. We do run 16. We do run as configured here, which I think works out to 16 per core, if you've done the math already. But there is not a limitation, but also it also has to do with the number of processes you run on each box. But we'll check into that. If you want to give me your name afterwards, I'll check with our architects on that, just to double check. Question over here.
Talking about EMS Online, I assume it does, but just want to double check. Does it support the API? Because we pull a lot of information out of Tableau.
So the question is, does Tableau Online support the APIs? Because my company needs to pull a bunch of data out of the server.
So the answer is yes. We support fully all the REST APIs and even the extract APIs, the TD APIs. Every of those APIs is supported in Tableau Online.
Another question.
I was wondering, in the AWS implementation, how do you sync the Postgres databases so that if I publish in one AZ, that it's available immediately in other AZs?
So the question is, in the AWS Online implementation, how do you sync between the 2 availability zones? So if I publish to one, it's available in the other.
Right. So this is where we went to AWS for this reason. RDS makes it happen for us. So if we have a failover, so for example, a primary AZ database goes down, RDS, we've done the test, and within seconds, they fail over to an instance in another AZ, and the data is replicated there. So RDS takes care of that for us. There's some configurations that we build in.
You use the Postgres RDS implementation.
Yes.
Next question. No, that's it? Plenty of time to ask questions. Or we can, okay, go ahead, Mark.
Again, the Alpha A versus Alpha B,
Oh.
sorry.
I just got off that
That
one.
was very close to my configuration, by the way.
Okay.
This is why. My question this time is more like a data engine versus file store configuration.
Versus that. Okay, so Mark's question is, hey, my configuration is very close to this Alpo configuration that you showed, Joe.
You have one file store with one data engine. I have one file store with 2 data engines. I forgot how it came up here.
Yeah.
I don't know why you have that.
So the question is, Mark's question is, why on this diagram do you have one data engine for only 3 of your workers? And in my configuration, I have more data engines. I'll have to actually take some information from you to get the details of that, because there's some nuances that, for the reason we do this, around the amount of available processor actually that we want to make available to the data engine, and so it was a configuration choice by us. But I will take that back if you get with me after the session.
Between the data engine versus the file store, you have one-on-one ratio.
The file store is always in a single location and replicated to multiple locations. So the question was, hey, you have 3 data engines and 1 file store. In all cases, the data engines only ever access one of the file stores. The file stores are replicated for HA, but if the primary file store was to have a problem, you would fail over to the secondary file store, and it would only all data engines would only access that one file store. Another question.
It's kind of piggybacking off of, I think, Mark. Yeah, basically, with my company, we also have multiple data engines. It was recommended due to our high I/O, like we keep meeting these high I/O thresholds to do that data engine process. We need more data engine processes. That was a recommendation that we received.
So the question was, hey, in my company, we ran into a lot of high I/O due to the data engine process, and I see you have 3, and we were recommended to go more. And my answer to that would be, my recommendation would be to go to more on more boxes, more servers, because remember, the I/O is going to, depending on where you're seeing the I/O bottleneck, and you'd have to talk to or look at the disk queue length basically on the servers that are involved. The I/O is either going to be on the file server instance or on the data engine instance. If it's in the data engine instance, you can spread that out wide and add more data engines. If it's on the file server instance, then you're going to have to look at what can I do to the disk subsystem to increase I/O capacity.
Yeah, we end up doing both, by the way.
What's the version you have? Production version?
The question is, what production version do Alpo A and B run? 10.1. We are in 10.1. We're always on the latest version because, back to my earlier story, it goes to public, then it goes to Alpo, and then it goes to y'all.
Do you find any performance changes between 9.something to 10.0 to 10.1?
Yes. The question was, do we find performance changes between 9, 10, and 10.1? 10.1 has actually been remarkably good performance. So we've seen great improvements in all facets of performance on 10.1. If you want more details than that, I'll have to get you like where are the specific areas. I don't have those off the top of my head.
I just upgraded to 10.0 if I came here. Now I have performance issue.
All right. So the response was, I just upgraded to 10.0 before I came here, and I have performance issues. He upgraded from 9.0, 9.2 to 10.0 and has performance issues.
Yeah, I probably have about 10% slower.
Okay.
Well, we ended up doing the same thing over the weekend, basically 9 to the 10.0, and we have pretty big deployment too, and we didn't see any performance issues.
No, you don't have that issue.
Yeah, we didn't, but then again, at the same time, we added more power.
Okay.
On the same weekend.
So, Mark, I don't know the answer, what I can tell you about that other than let's make sure and get a call into support or get your performance person out there. We'll definitely help you in any way we can figure that out. Any other questions? Feel free to go, by the way. You don't have to sit here and listen to me jabber.
So what is the difference between 10 and 10.1? Because same thing, I just upgraded 10, but I come here, everyone seems to use 10.
Yeah, I actually don't have the list. The question was, what's the difference between 10.0 and 10.1? I actually don't have the list off the top of my head. There was a couple. I know there was a couple ones that people were waiting for.
I can talk about some of the features.
Okay.
So we added some connectors in 10.1. So you have market hosts, some of the new connectors in there. We did some performance bugs that we fixed, and we made some improvements in our query caching. So you'll benefit a little bit better with 10.1 if you're comparing it with just 10.0.
All right. One last thing before we go, unless there's other questions, is please do go to the survey app. Go to on the app on your phone. Go survey and please fill it out so we know how to improve this session going forward, and that hopefully they still let me and Ops Guy talk to our customers because I really enjoy it. All right. Thanks, guys.
Thank you, guys.